I'm Anil Kumar. I have taken a few videos to sketch the graph of the function when first and second derivatives are given to us. Here the question is, sketch graph of a function with following characteristics. F of 2 equals to 4, that means at 2 the value of the function is 4. Second derivative of the function is greater than 0 for x not equal to 2. So elsewhere it is greater than 0. Then we have limit as x approaches 2 from the right side for the derivative of the function is minus infinity, and limit when x approaches 2 from the left side for the derivative of the function is plus infinity. You can pause the video, sketch a graph of the function that meets these criteria, and then look into my video for suggestions. Normally, when we have to do this kind of a sketching, then while we read the information, it is a good practice to put them on the graph paper. Right? So let's say this is our graph paper. Here we have this x-axis and the function f of x. That's the origin. The first condition here is that f of 2 is 4. So let's say this is 1, this is 2, this is 3. So at 2, the value of the function is 4. Let's say this is 4 for us. Okay. So this point is on the graph of the function. Now what we're given here is that the second derivative is greater than 0 for all values except 2. So second derivative is greater than 0. That really means that the second derivative is positive, right? So it means it is positive. If second derivative is positive, we expect the graph to have what kind of shape? It should be concave up, right? So that makes the second derivative positive. That is to say that except for at point 2, the rest of the places we are talking about a shape which is kind of like this. Do you see that? Now this shape itself gives you the major characteristics of the graph. Now once you have this kind of a shape, with this you can analyze the other conditions. It says that the first derivative, when you approach 2 from the right side, is minus infinity. So from the right side you can see this tangent, if you draw, which represents the first derivative, is kind of going downwards, negative. As you approach 2, it becomes more and more higher negative value, or you can say negative infinity. So that fits in. Now limit when x approaches 2 from the left side for the derivative of the function, that means tangent, right? So we are saying we are talking about tangent, right? When we talk about the first derivative, correct? So it is positive infinity. So here you can see that the tangent has a positive slope as you approach 2. So this is the point where x is equals to 2. It becomes more and more positive, right? So that means that is the shape of the graph. So with this shape we can actually sketch the graph. So let me just take a colored pen to shape it, to sketch the graph, and we can say something like this, right? So we can draw a graph like this. So that kind of a graph will meet all these criteria, right? So we are already given that this point here is actually 2, 4, and that is a cusp here, right? And the graph is concave up during the interval minus infinity to plus infinity, except for at x equals to 2, right? So at this point we have a cusp. So that is how you could actually sketch a graph from the given conditions. I hope that helps. Thank you and all the best.